I hate all of you.
Especially
That's what they all say.
What?
Yeah, I've heard that before.
And we're live!
All right.
Oh, they didn't get the CRB, dude.
Hey, is the bell ever gonna ring or like?
I don't know, we're just gonna go.
I
All right, so here's the deal. We're gonna start off with the easy stuff, and then we're gonna get to the reflections, which was the song of the day. You get it? Did you get it? Did you get it? Okay, so here we go. Quiz tomorrow is gonna kick your butt. I would advise you.
I showed the stream.
Shut up. I would advise you to watch period 6 class from yesterday, because that's when I hit my stride. Normally I hit about 4th hour, right? But
Yeah, so
it really clicked for 6th hour. So I would encourage you to watch that if you're still struggling with reflections. Hopefully you'll get a little bit more closer to getting it today. That's only about half the exam though, and you can probably do about half the reflections. You're probably struggling with the back half of it, the midpoint and all that, right? So even if you're still struggling with it, you still can pass. It'll be okay, right? Let's get the vectors out of the way because this stuff can be easy. So check it out. It says we have these vectors. It wants us to sketch each vector. We can put it anywhere on the graph. I'm going to do 4 of them. I'm going to do this one in red. I'm going to do this one in blue. I'm going to do this one in green. I'm going to do this one in orange. Let's go. Let's go. So, vector V has component 3, -6. That means 3 in the horizontal, -6 in the vertical. You can start it wherever you want. Remember, vectors are movement. They're not coordinates. So you can start it wherever. I'm going to start my vector V here. And then from that starting point, I'm going to go 3 to the right and 6 down, because that is the components of vector V. 3 to the right, 6 down. 1, 2, 3, 4, 5, 6. And there we go. We're going to label it. Remember, to label it, you want to have an arrowhead that's only half. We call that a harpoon. Vector V. Cool? Next one in blue is vector U. It's 2, -1. So I'm going to choose a random spot to start it. And I'm going to go 2 to the right and 1 down because that is the components for vector U. Those are, I should say.
You can start them anywhere, correct?
Right? Yeah, you can start them anywhere. Right? These vectors are copy and pastable because when you apply a vector, you can apply it wherever you want. It's just going to move a dot. Right? That's the idea. Vectors are movement. A is 8, 0, which means 8 in the horizontal direction, 0 in the vertical. So I'm going to start it here. And I'm going to go 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And again, direction matters. Make sure your arrowhead's heading in the correct direction. I started here, and I headed 8 to the right, so my arrowhead's going that way. That is vector A. And then lastly is vector B, which I'll start here. It is 3 to the left and 0 up. Now you can probably tell which vectors are parallel. A and B out of the ones that I graphed. There's more up there, right? A and B are definitely parallel. Now, we can see that, but what if we can't see it, right? What if we're not sure? It looks close, but we're not sure. The way you check is you compare their components in a ratio, meaning a fraction, right? So vector A's components are 8, 0. So I'm going to write with the 0 first and the 8 second. So vertical, then horizontal, kind of like slope. You could flip it, doesn't matter, as long as you're consistent. 8 over 0 is the same thing as 0 over -3. Right? We have A's components, 0, 8, or 8, 0 I should say, and we have B's components, -3, 0. When we write them as a ratio, again, vertical on the top and horizontal on the bottom is how I did it. You'll notice that 0 divided by 8 is the same thing as 0 divided by -3, right? So when they're the same in ratio, that means that they are parallel. So vector A is parallel to vector B. We're also going to find the magnitude in a second, but we'll pause for station identification. How do we feel about graphing vectors?
Pretty good.
Pretty good?
Light work.
Okay. If you're not sure, ask a question now so I can solve a problem this small. No? All right. A and B, when I write their components, I wrote the vertical component first and then the horizontal second, kind of like slope. You could flip them both, doesn't matter, right? They're going to be parallel. Is that cool? If they're equal. Notice that these two won't be parallel because first of all, they don't look like it. Second of all, if you write their components, you get -1/2 for this one and you get -2 for this, right? So they're not going to be the same, which means they're not parallel. Let's find magnitude. What is magnitude? What's the magnitude of a vector? What's the idea behind it? Yeah.
How far it traveled.
Right, exactly. The distance you're traveling, right? The length of the vector. So if we want to find how long something is, right? If it's at an angle like vector v is, we have to break it down into a right triangle and do p-fag. So it's going to be p-fag, right? Of its components. So the magnitude of vector v, and that's how you write the magnitude. I do it with 2 lines. You can do it with just the 1 on each side. I do it with double. The magnitude of vector v is going to be the p-fag of its components. So 3 squared plus negative 6 squared. And of course we root, because we want to know the length of it. Does everybody see how that's p-fag? A squared plus b squared equals c squared, and then we root to get rid of the c squared. Which means that the magnitude of vector v is going to be 9 plus 36, all under the root, which is going to be root 45 when it's simplified down. You're going to do that for all of them. I'm just doing it for the 1. How do we feel about finding magnitude?
Easy.
I hope so. And if not, that's okay. Let's make it easy. Ask a question. Evan, how do you feel? You've been gone.
Can I ask what the definition?
Magnitude is p-fag. Graphing vectors, pick a point, go in the direction it tells you. Yes.
So it doesn't matter where you graph it?
No, where you start it doesn't matter.
Okay.
Right? I could start vector v somewhere else. It would look the exact same. It would be like a copy and paste, right? But it can start anywhere. Yeah. What would you do for b? So if you wanted to find the magnitude of b, is that what you're asking? Well, it's negative 3 squared, which is 9, plus 0 squared, which is 0. So root 9, which is 3. Right? And if you look, b does have a length of 3, doesn't it? How do we feel? Graphing them, pick a point, do what it says up here. Do you know how to read what it says, Alex? Okay, horizontal then vertical. How do you feel about magnitude? Square 'em, add 'em, and root 'em. p-fag.
Pythagorean theorem. Your good news was listed growing.
Right?
And I'm still not on it.
Cool.
What is it? Sounds like McConnell.
McLovin is still on there.
Who's McLovin?
That's the only question you should be asking. All right, translate each pre-image by the given vector. The pre-image is the thing you start with. The image is the thing you end up with. I hate that name. I wish it was pre-image and post-image. I think it'd make more sense. Write the rule and then write the prime coordinates. You've never seen it listed like this because we haven't had a lot of homework recently because we've been missing days. I've been trying to cut that out to get more in class. But the format should not confuse you, so try to pick up on it now. If you're confused about the format, ask. Here's what we're going to do. We're going to translate by this vector, 6, negative 2. Horizontal component of 6, right? So 6 to the right is what we're doing. And then negative 2 down. So every vertex is going to be 6 to the right, 1, 2, 3, 4, 5, 6, and 2 down. So A prime is going to end up here when we translate it by the vector. Now we're going to do that to every single vertice. There's the vector, right? We're going to do it to C, 6 to the right, 1, 2, 3, 4, 5, 6, and 2 down. That's C prime. And you'll notice these vectors are all the same, right? We're applying the same vector to each one. That's what a slide is, a translation, where we slide everything the same amount. We do it to B, 6 to the right, 1, 2, 3, 4, 5, 6, and 2 down. B prime ends up here. Is everybody cool with moving those dots by the vector?
See.
6 to the right, 2 down? Do you know where I got that 6 to the right and 2 down from? Awesome. After we move it, we're going to connect our dots. So we move the entire image.
I wish they would just bring it up.
There it is. Yeah, I know, right? It's kind of frustrating they overlap.
Never made that as a day.
I know, what a loser. So, the rule. Your original coordinates are xy, right? Some xy. What did we do to the x? Well, we added 6 to it, didn't we? So, the rule is, add 6 to your x. What do we do to the y? We subtracted 2, y minus 2. So your old coordinates are here, and your new coordinates are the same thing, except you add 6 and then minus 2. That's the rule, right? So when we apply this rule, here's A's coordinates, negative 6, 6. If we add 6, what's negative 6 plus 6? 0. What's 6 minus 2? And look, A prime does end up at 0, 4, right? So you can either take the points that you got here and write them in, or you can use the rule, or you can do both and check your work, right? If I'm at -8 and I add 6, where am I at now? -2. If I'm at 1 and I subtract 2, I'm at, and look, B is at -2, comma -1,
That's crazy.
right?
Is it gonna be like this on the test?
Yeah.
Oh, Betsy.
-1, add 6. 5, 0, minus 2. -2. 5, -2 is where C is, right? Do it in either order, right? Figure this out and then plot your points. Cool. Or do this and then carry it over. Or do both and check your work. I'm going to leave number 3 for you to do. Questions on this? How do we feel about applying vectors? Translating. Feeling better? Okay. I think the other day ago you're like, oh, I don't remember that at all. But it's not bad, right, if you know what you're doing. Okay? Yeah, classic. Turn the page. Number 4. They gave you the before and after, right? You're going to find the vector that did that. So, if we go from A to A prime, which is what we're going to do, right? We go towards prime. Prime means new. Here's the vector we're applying. Now, if this is a translation, it should be the same vector for everything, right? B going to B prime, D going to D prime, and C going to C prime. They're all the same vector. They're just moved around, right? Copy and pasted. That's what a slide is. And again, direction matters. We're going towards the primes. Don't screw that up tomorrow. They want to know what the vector is that we applied to get from A to A prime. Well, let's look at B to B prime. It's going to be the same for all of them, right? So let's pick this one because it's easy to look at. You don't have to do this. I'm going to do it so you know where I'm doing. Looks like from B to B prime, I went left 3, so that's a -3. Again, direction matters. And then I went up what I believe to be 9.
10.
Yeah, it's 10.
10, yep.
Jeez.
Up 10. So the vector that we did, again, pointy brackets, we're talking vectors here, was -3 in the horizontal direction and +10 in the vertical. That's the vector we applied to each of those vertices. That's it. Now we got to find the magnitude, which is the length of the vector, right? Pfat, right? -3 squared, 10 squared, root it, you get the length. So let's do that. Square and add the components, then root them. That's 9 plus 100 under the root. So that's root of 109. That's the magnitude. Rest in peace.
At this one now.
I know. More plastic to ruin our world. There is no planet B.
But there's planet A.
Yeah, you're ruining it. Horrible human being.
No, I'm not.
Leave a comment if you think Danny's a horrible human being.
Alright,
Questions on this? I'm going to leave number 5 for you spoilers.
When you're
We're going to the left. Don't goof that up. We're heading to left some number. Do we go up at all? No, so it's going to be 0 for the vertical, right? That's going to be easy to find magnitude. You could literally count it. Turn the page. Number 6, it's reflection time. Let's do this. First, we're going to read the directions. It's a lot. It says reflect each point over the given line of reflection. Okay, so that's just the general thing we're doing, right? We're flipping the point over the line. It says first plot the given point and the line of reflection. If you don't know how to do reflections, I bet you know how to plot a point and plot a line. Get those points. Don't leave this blank. So, first off, let's draw our line of reflection. It's -x plus 4 in slope-intercept form. So our y-intercept is at 4. 1, 2, 3, 4. What's our slope? What's our slope of this line? Down 1 over 1, right? So this is our line of reflection. That's right. The only thing worse than having to read social media is having to hear people read social media out loud. All right.
I know, that's the worst.
I know. So, A is 1, -3. That's here. That's 3 points already. How do you feel?
Easy. That's easy.
Good about graphing the line, good about the point? Okay, now we're actually going to do the reflection. First of all, reflections always happen perpendicular to the line of reflection. So we need to find the perpendicular line, right? So if this is the original line, our perpendicular line is going to have what kind of slope? What's the slope going to be? 1, right? We flip it and change the sign. The original slope of this guy was negative 1 over 1, right? So if we flip it, we still get 1 over 1, and then we change the sign, so now it's positive. We don't know what b is yet. B is going to make it go through 1, negative 3. So we're going to plug in that point to this. Negative 3 for y, and 1 for x. There's the perpendicular line. I'll pause for station identification.
Thanks for explaining.
Do we see how I flipped and changed the slope sign?
Yes.
Do we get that?
Yes.
I plugged in the point they gave us because I wanted to go through that point. Negative 3 goes for the y because that's the y value. 1 goes for the x value because that's the x value. I do math. I find out b has to be negative 4 for that to work, right? So negative 4 down here. Do we see how 1x is the same thing as x? Right? Cool. So that's the perpendicular line. Let's graph it. Negative 4 on the y-axis is our y-intercept, and then our slope is up 1 over 1, right? It better be, otherwise it wouldn't go through A.
Have you ever tried that?
We don't have to graph the red line, because sometimes the red line can be gross, right? But this one's not bad, so I'll graph it. That's what it looks like. That means that A is going to be somewhere on this side on this line, right? When we flip it. Because all reflections are perpendicular to the line of reflection. So now that we've done that, we need to figure out where the lines intersect. Now, could you eyeball this? Oh yeah, you could, right? They intersect right here. That looks like 4, 0. That's going to be our midpoint for midpoint formula, right? But we need to do the math because later the numbers won't be as nice. I gave you nice numbers, which means it's eyeballable, right? That way you wouldn't be intimidated. So take advantage of that now and practice the math. That way when the numbers do get weird, that's the only difference, right? Is that the numbers are weird, we're used to the process. So let's figure out where these lines intersect. We're going to do that by setting the two equations equal to each other, right? So the original equation is negative x plus 4. And the perpendicular equation is x minus 4. Right? They both equal y, so they equal each other. I'm setting them equal to find out where they intersect. Are we cool with that? Awesome. So now I do math. I'm going to add the negative x over. Again, this is just how I'm doing it. You might do it differently. I'm going to add the negative x over, which makes that a 2x. Doesn't go away, right? We get 2 x's. Then I add the 4 over, and I'm going to get 8. Don't lose your equal signs. Then I divide by 2, which means x is 4. So our midpoint, where they intersect, is going to be 4 comma something, right? We found the x part. Now we need to find the y part. How do I find the y part? Yeah. Right, I can plug it into either equation because they both agree at x equals 4, right? So they're both going to pop out the same thing. If I plug it into the blue equation, I get negative 4 plus 4, which is 0, right? If I plug it into the red equation, I get 4 minus 4, which is 0. See how they agree? If they agree, that means they intersect. So we get 0 for y. Does everybody see how I got the 0?
Yes.
Decker, you with me? Awesome. Xavier, you with me? Are you with me?
That was a little hesitant.
We graph the blue line. We flip the slope. This was the original slope. We got positive 1, right? Because we flip it and change the sign. Stay with me. Then we solve for b by plugging in our point. We got b is negative 4, so that means this is the perpendicular equation. I graphed that. That means a prime is going to be somewhere over here, right, on this line. I set those two equations equal to each other so I could find out where they intersect. They intersect at 4, 0. Now I'm going to use this intersection as part of my midpoint formula. What is midpoint formula?
Average of the x's over average of the...
The midpoint is the average of the x's and the average of the y's. When we average stuff, Xavier, do we add or subtract? When I average things together. Exactly. And then we do what? Anybody? Divide by the number of pieces. So we have 2 x's, so we're going to divide by 2. Same thing with our y's, right? That's midpoint formula. We know the midpoint. The midpoint is 4, 0. So that goes over here, right? Because m is 4, comma 0. We're adding because we're averaging. Now, normally when we do midpoint, we plug in the stuff here, and it gives us the midpoint, right? Well, we already know our midpoint, and we know one of the endpoints. It's A, the point they gave us, right? So we already know one of our endpoints. I'm going to plug in my endpoint A here, 1 for x, negative 3 for y. I don't yet know these guys, so I'm going to leave them as x and y. That's going to be our A prime. That's what we're looking for. Okay? The x and the y there is going to go here. So already see where I plugged that stuff in and why I plugged it in where I did. That's the midpoint, so it goes for m. It's a coordinate. This whole thing is a coordinate as well. That's the x part, that's the y part. No yawning in math class. Here are our 2 endpoints. I know one of them, so I plugged it in. That's A. The other endpoint is A prime, the thing we're looking for, right? The flip. So now let's do this in our heads. I know that this part should equal 4, right? So I'm going to get x on its own. I need to get rid of the divides by 2. How do I get rid of divides by 2? Times 2. If I double 4, what do I get? 8. So now I'm here. X plus 1 equals 8. How do I get rid of the plus 1? Subtract it, right? If I have 8 minus 1, what do I have? 7. So x is 7. You see how I did that?
Yes.
So A prime.
This is going to equal 0. No yawning in math class. Get rid of the divides by 2. How do I get rid of the divides by 2? Double it. Double 0. Still 0. How do I get rid of a plus negative 3? Well, plus negative 3 is just a minus 3, right? So I add. I add 3 to 0. What do I get? 3. So A prime should be at 7, 3. Let's graph it for our last bit. 1, 2, 3, 4, 5, 6, 7, up 3. Oh, yeah, it is on the line. We did it.
That's awesome.
How do you feel?
Just kidding.
Good.
Katie's bored. Easy.
I am cool.
It's fine. I wouldn't say it's
Math class.
All right, let's talk about the concepts, okay? Because you need to think about what you do and when, all right? First off, graph the original line and the point. Ain't no thing, I hope. Find the perpendicular line, right? We need perpendicular slope and we need to find B. Find out where they intersect. Use the intersection to find the flip. How you feel? Yeah, me too. I stayed up until 2 a.m., but I feel great. Lately, I've been getting lots of sleep, which for me just doesn't work. I need like 4 hours, and that's when I'm like,
4 hours.
yeah! All right.
I need you to reenact that.
Yeah.
We're live. All right. You want to do 7 or you want to do the next one?
Do it.
All right.
Do it again.
Nope.
Do it.
You guys ever seen David After the Dentist?
Ever seen David Stringwell?
Shout out to David. All right. First thing we need to do is we need to graph our original equation.
I gotta go to YouTube.
Y-intercept at 4. 1, 2, 3, 4. Down 1 over 3. Wait, the face cam didn't get it?
It's too little.
Oh.
Where is it?
I want you to watch this one. Don't write it down. So I'm graphing the original line, right? Y-intercept at 4. Our slope is down 1 over 3. Cool with that?
I think I got a decent.
1, negative 3 is the point we're going to flip. That's A. Same point as last time, actually.
Yeah, this is the best thing to get.
Now we're going to find the perpendicular. Perpendicular lines have perpendicular slope. Perpendicular slope is flip and change the sign, right? Our original slope is negative a third. So our new slope is going to be positive, right? What happens when we flip 1 over 3? What do we get?
3.
3 over 1, which is just 3. Now we're here. I'm going to find b by plugging in my point, because I want the line that's not just perpendicular, because this will be, right? But I also want the one that goes through 1, negative 3. There are lots of lines that are perpendicular to this one, right? I can draw lots of them. The thing that's going to set this apart is going to be what the b value is, because that's going to make it go through a. So, let's plug in our point. 3 for y, because that, or negative 3 for y, because that's our y value. And 1 for x. Good? Stay with me. You're fading in and out. We get 3 here, and negative 3 there. I'm going to subtract 3. I get negative 6 for b. So that means our line is going to be y equals 3x minus 6. That's our perpendicular line. I don't have to graph the perpendicular line, because sometimes it's going to be gross. But this one's not bad, so I'll do it. Down 6, 1, 2, 3, 4, 5, 6. That's our y-intercept. Then we do up 3 over 1. Oh, look, it does go through a. If I keep doing that, I'll get a more accurate line. So there's our perpendicular. A prime is going to be somewhere over here on that. You can probably eyeball it, can't you? It's going to be like right there.
Up 3 over 1.
If the numbers are nice, which for this one they are. Now we need to find out where they intersect. Again, you could probably eyeball it. But we're going to do the math anyway. That way when the math does not look nice here, we can still have a way of figuring it out. So how do I figure out where lines intersect? What do I do? What do I do with their equations? Yeah, I set them equal to each other. They both equal y. So this should equal that. So I know 3x minus 6 should equal negative a third x plus 4. The question is, where do they intersect? Where do they equal? Where do they agree? Right? So now I'm going to do some math. So hang on to your butts. I'm going to add 6 to this side, and we get 10. I'm going to add a third x to this side to move it over, right? So 3x is already there, and I'm adding a third x to move the whole thing over. We need common denominators. The question is, how many thirds are in the number 3? 9 thirds. Because 9 divided by 3 is 3, right? 9 thirds. Another way you can think of it is 3 over 1, and I need to make that a 3 on the bottom, right? So I multiply it by 3, so I multiply the top by 3. Right? That's how we get common denominator. If I've got 9 thirds, you've got 1 third, how many thirds do we have? 10 thirds.
I was just kidding.
What a dingus.
Right?
All right, we have options now. This is 10x divided by 3, right? 10 times x divided by 3. Do you want to get rid of the times 10 or to divide by 3 first? Times 10. How do we get rid of times 10? Divide by 10. What's 10 divided by 10? 1, so it goes away and becomes a 1. And then we times this by 10, we get 100. Right?
Ew.
Yeah, definitely.
Don't lose your axes. Oh, we weren't supposed to write this down.
Mr. Mack, what did you do? Why don't you
It's
just
gross.
times by-
It's
Why don't you just times by
33.3333333 or 66.
No, why don't you divide by 3?
No, you're multiplying by the
Why wouldn't you?
How did I get from here to here?
You
I divided by 10. What did I do to get from here to here?
you multiply.
Oh, no, I goofed it.
Dang it.
I'm supposed to divide by 10. What's 10 divided by 10? 1. Oh, much better. Now, how do I get rid of divide by 3?
Multiply.
When I do that, I get 3 over 3, which is 1.
You dig.
If you want to get rid of the division first, I would encourage that. It's a lot easier to think about. Times by 3, we get 30. Divide by 10, we get 1, right? That's fine. I said it. I didn't write it. We'll let it slide. All right, x is 3. Again, I multiplied by 3 to get 30. Divided by 10 to get 3.
I got a reflection of you.
Awesome. So this is 3 comma something is where they intersect. How do I find the y part? I plug it into either equation because they both agree that at 3 they should pop out the same thing, right? They're going to intersect. So I can either plug it into the top equation, or I can plug it into the perpendicular equation. Which one do you want to plug 3 into?
Perpendicular.
Okay, what's 3 times 3?
9.
Subtract 6. 3, they intersect at 3, 3. Yeah, they do.
Dude.
So that's the intersection. You could have plugged it into the top. 3 times a third is 1, negated is minus 1, plus 4 is still 3. Right, they agree there. That's where they intersect.
Agreed.
Now that we found where they intersect, we're going to take that, and we're going to put it in our midpoint formula. What is midpoint formula?
Average of the x's and average of the y.
Good, so 3 comma 3 is going to equal the average of our x's, the average of our y's. No yawning in math class.
How do you know somebody's he's got eyes on the top of his head too?
Our original point is 1, negative 3. Let's solve this in our heads. We're looking for a prime. We double this, we get 6, right? So now we're here. We subtract 1 and we get 5. I'll do that again. These two parts equal each other. So I double it and I get 6. And then I subtract 1 and I get 5. Cool?
Yeah.
5 plus 1 divided by 2 is 3. This part equals this part. I double it and I get 6. How do I get rid of a plus minus 3? In other words, how do I get rid of a minus 3? I add it, right? So I doubled it, I got 6. And I added 3 and got 9. 5, 9. That's all I am. So 5, 9. 1, 2, 3, 4, 5. Up 9. 1, 2, 3, 4, 5, 6, 7, 8,
1, 2, 3, 4,
9.
5,
There's a prime.
3, 4, 5, 6, 7, 8, 9.
There's the flip.
A1.
All right. You weren't writing this down. Great. How do you feel about graphing the blue line?
Oh, we weren't writing it down?
No. How do you feel about graphing the blue line?
I wrote it down, so it's where.
How do you feel about plotting the original point?
I think it's easy.
Excellent. That's 3 points. How do you feel about finding the perpendicular line?
Easy.
Flip and change the slope.
Easy.
Plug in your point.
Easy.
If it's not, that's okay. It can be easy. So ask your question and I can show you how easy it is. I promise. Then we find out where they intersect. And things get weird, right? Now we have fractions. We need common denominators. That's what makes this problem a medium difficulty. 9 thirds and 3, right? Again, check your work. 9 divided by 3, is that 3? Yeah, so we didn't change the problem. We just made it look different. That's 9 thirds plus 1 third is 10 thirds. Get rid of divides by 3 by timesing by 3, we get 30. Divide by 10, we get 3. Okay? Here we did it differently. We divided by 10 first, then times by 3. PEMDAS is a lie. So we got 3. We plugged it back in and got 3 again. We put that into midpoint. We solved. Do you feel better?
Yeah.
Good. Evan! How you doing?
Good.
Really?
That's a big one.
Okay. 10 is tough. It's the hardest it can possibly be.
No, it's not. I bet it's easy.
Dude. Biscuits.
I can do
Looks
it.
like all the other ones. You
All
I'm
right.
gonna do it right now, Mr.
I can do it.
We've got less than, what? We get out of here 39?
8 minutes.
So we got 8 minutes? Let's try it. Watch, do not write. There's no way in hell you're going to keep up with me. Let's be honest, okay? Come
I'm
on.
just not gonna watch and do it.
I'm
by
beating
myself
you.
and see if I
Right
can-
here, we're going to graph the original line. What's our y-intercept? Play along at home. What's our y-intercept? -4, thank you. Then we do our slope, which is down 3 over 4. Down 3 over 4. Bam, there it is. I'm going to draw my line. Here's the line of reflection. I've already got 2 points. Literally and otherwise. Now I'm going to graph my point, which is 1, 3. There's A. I need to find the perpendicular to that. The perpendicular is going to have perpendicular slope. I flip it and change the sign, so I have 4 thirds and it's positive. Plus B. Stop writing this down. There's no way you're going to keep up. I plug in 3 for Y. I plug in 1 for X.
Stop worrying.
I can easily catch up.
I get 4 thirds plus B equals 3. I'm going to subtract 4 thirds. 3 minus 4 thirds equals B. I need common denominators. How many thirds are in the number 3?
9.
9 thirds. So B is going to be 9 minus 4, which is 5 thirds.
Wow.
Which means our perpendicular line is Y equals 4 thirds X plus 5 thirds.
Girl.
There's the perpendicular. I'm not going to graph that because I don't have to. But I am going to use that slope. If I go to A, which is on that line, right? I'm going to use my slope. Up 4 over 3. 1, 2, 3, 4 over 1, 2, 3. Oh, look, I could graph it if I wanted to. 1, 2, 3, 4 over 3. Ain't so bad. Down 4, back 3. Down 4, back 3, something like that. Okay? So what I'm going to do is I'm going to find out where these lines intersect, right? It's not going to be at a nice point. So I do need to use the math. So I'm going to set them equal to each other. I've got the original equation, which I'll write in a second, and then I've got my perpendicular equation. Here we are. Original equation is negative 3/4 x minus 4. You with me? We're going to find out where they equal each other. So first off, I'm going to add 4 to this side. That's going to be 5/3 plus 4, and I'm going to subtract 4/3 from this side. I need common denominators. How many thirds are in the number 4? 12 thirds, because 12 divided by 3 is 4. So I've got a total of 17 thirds over here. Over here, I need common denominators. I can't just think how many is what and what, right? I need to get common denominators. I'm going to multiply the 4 and the 3 together. What's that? 12. So 12 is going to be my common denominator. How did I make the 4 into a 12? I multiply by 3. So I multiply the top by 3. I get negative 9. How did I make the 3 a 12?
Times 4.
I multiplied by 4. Don't goof that up. So I multiply the top by 4. I get negative 16. Negative 9 minus 16 is negative 25 over 12x.
Ew.
Now we're going to multiply by 12 and divide by 25. Yikes. What's wrong? When I multiply by 12 and divide by 25, we can do it in any order we want. How about I do 12 divided by 3 first? What's that? 4. So I did 12 divided by 3 and I got 4. Let's do 4 times 17. What's that? 40. What's 7 times 4? 28. So it's 68 over negative 25. So x is negative 68 over 25. Yikes.
That is
So negative 68 over 25 for x. Let's find out what y is. I got to plug it into one equation. Which one do you want to plug it into?
You did that on purpose.
Red or blue? Red?
Blue.
There's more fractions than this. Let's do it in blue. All right, so I plug it into blue. Negative 3/4 times whatever our x is minus 4. That's negative 68 over 25. All right?
That's nasty.
How about we do negative 68 divided by 4? Does that come out evenly?
Negative 68.
Yes, it does.
What's 60 divided by 4?
Of course it.
15. What's 8 divided by 4? 2. So it's negative 17 over 25 times negative 3. So I got to do that. Negative times negative is a positive. What's 17 times 3? 30 plus 21. 51 over 25. We need common denominators. How many 25ths in the number 4? Hundo. 51 minus 100 is negative 49. That's M. We're not done yet.
Of course we're not.
Yeah, stop writing it down, you dinguses.
Yeah. There's just 8 in them.
What? Yeah.
It's really easy.
Average of the x's, average of the y's. When we average, do we add or add or subtract? Can you guys stop being so obnoxious? Your nose blowing. Our original point was 1 and 3. Here we go. Multiply it by 2. Negative 100 and what? 36 over 25. And then we have to subtract 1 from that.
I swear, if this is on.
Multiply by 2, we get negative 98 over 25. We have to subtract 3 from that. Let's get common denominators.
I'm walking out there.
25 25ths, it's going to be negative 161 over 25. How many 25ths in the number 3? 75, very good. So negative 183 over 25.
That's disgusting.
And that is where A prime's going to end up.
That's
That was
That's
for your own
horrible.
fun. That was for your own
That's
entertainment.
horrible.
We all know, Mr.
If you can do all the ones except for 10, you're gonna be fine.
Can that be extra credit
Can like
on the test?
I don't think
I followed
I don't think
you and
anyone
kept up
can
on it, and I looked away, and then I looked back.
I could do that. Mr. Matt, you should have that as the lost problem, and it's extra credit. And I can do it. I can solve this thing.
What a frickin' dingus. How do you feel?
Yeah.
Other than 10? Pretty good?
Yeah.
Like, the fractions suck, but other than that, you know what you're doing, right?
I might be in your drink.
Of course, I do. I know.
Of course!
Dude.
Flashlight on.
I didn't know birthdays. Get back here.
Put it up where you can't reach.
I swear.
By the moon and the stars in the sky. Danny, actually? Oh man, they grow up so fast. All right, everyone, go away. I'll see you tomorrow. Destroy this exam.
I have evidence
Yeah.
of you taking students'
Yep, that's right.
Yeah, I'm putting it where they can't
Yeah,
run.
but Xavier, you
Jessica.
wouldn't if you paid attention in class. So how about you come and pay attention some other time? That way we can get you caught up.
Just because of that, I'm taking your privilege.
Do you know what you're doing?
Oh, that almost went in.
Oh.
Don't trip on it, Evan.
Check it out, Dakota.
During.
It's my
Yeah, I
spot.
can't today because I have a stupid freshman academy lesson.
I don't want to go to
Danny, big solution.
That's the only class I have a B in.